Just a few months ago, the internet started buzzing about a seemingly pointless idea. Not just running Linux, but a full-fledged version of Windows on Nintendo consoles. I absolutely love things like this, and judging by your reaction, you clearly enjoyed the video about Linux on the PlayStation 2. So I thought, why not turn our attention to Windows on Nintendo? A GitHub user known as Wacko first developed software and drivers in July last year to run Windows NT 3.51 and 4.0 on Apple's Power Mac computers. Then, in March this year, he ported all this fun to the Nintendo GameCube, Wii and Wii U. It's important to emphasize that this isn't emulation, like when people just run DOSBox via the Homebrew channel and try to slap on a painfully slow Windows 95 on the Wii or Wii U. No, this is a full native launch of Windows NT on these consoles. This clever trick is possible because Windows NT 3.51 and 4.0, up to Service Pack 2 inclusive, were officially released not only for the x86 architecture we all know and love, but also for DIC Alpha, MIPS and PowerPC processors. And as it happens, both Power Macs and the GameCube, Wii and Wii U are all based on PowerPC CPUs, though not without a small caveat.
Hello YouTube, my name is Victor and you're watching the Russian Video Game Comrade Show. Today I want to invite you to yet another obviously ridiculous and incredibly useless journey to Windows on the Nintendo consoles.
Windows NT, which stands for New Technology, was developed by Microsoft starting in the early 90s in parallel with the classic Windows 1, 2 and 3 series. Its first version, NT 3.1, was released back in 1993. Interestingly, even that version supported not only x86 processors, but also MIPS and DEC Alpha CPUs. PowerPC support was only added 2 years later in NT 3.51, released in May 1995. Technically, the very first PowerPC version of NT came out a year earlier, in 1994, but it was an exclusive build for IBM, meant only for a single machine, the IBM RS-6000. Even more interesting is that the publicly available NT 3.51 and NT 4.0 versions with official PowerPC support were never intended for Macintosh computers. And it's rumored that this wasn't just because Microsoft and Apple were rivals. In fact, licensing Windows NT for use on Macs was considered by the bitten Apple during the operating system crisis following the failure of Project Copeland, Apple's cancelled OS, that was meant to replace the classic Mac OS 7 in the mid-90s. According to unconfirmed reports, Gil Amelio, who was Apple's CEO at the time, negotiated with Bill Gates on this, and Gates allegedly promised to assign hundreds of engineers to the project, including porting the macOS Quick Draw graphics library to Windows NT. Apparently, the offer was still being discussed as late as 1997, even after Apple acquired Next and Microsoft had ended official support for PowerPC systems. Jumping ahead a bit, I think that's all probably just rumor. The main challenge in porting NT came from differing approaches to PowerPC architecture standards and how multi-byte data is stored. Windows NT operated in little endian mode, meaning data is written from the least significant byte to the most significant, while macOS and Linux for that matter used big endian mode, which does the opposite, from the most significant byte to the least. On top of that, Windows NT was developed for systems based on the PowerPC Reference Platform, or PrEP, a hardware architecture standard for PowerPC systems defined by IBM. Motorola also used this standard in its computers, and ultimately became the primary consumer of the PowerPC version of Windows NT right after IBM. Apple, however, during its transition to PowerPC processors, developed its own specification, the Common Hardware Reference Platform, CHRP. This standard included elements of the Power Macintosh architecture and required the use of open firmware. The reason for this divergence was that PrEP was geared toward conventional PC hardware, whereas Macs were built on their own unique platform. Besides IBM, Motorola, and of course Apple, no one else really used PowerPC processors at any significant scale, at least not enough for a giant like Microsoft to bother supporting them. So, in February 1997, shortly after the release of Service Pack 2 for NT 4.0, Bill Gates' company decided that maintaining the PowerPC version of NT simply wasn't worth it. Even its two main users, Motorola and IBM, had already started transitioning to the more popular x86 processors from Intel. Windows NT itself, thanks to its stability and superiority over all those 95s, 98s, and your beloved Millennium Edition, became the foundation of the legendary Windows XP in 2001. To this day, NT remains the core of all modern Windows versions, including Windows 10 and 11.
But that's not what concerns us today. We're interested in the year 1996 and Windows NT 4.0 with Service Pack 2.
An operating system that seems to have haunted PowerPC enthusiasts for nearly 30 years when it comes to compatibility with Apple Power Mac computers. And you know what? It turns out that with just a bit more effort than writing forum posts, neither architectural differences nor endianness could prevent NT from being ported to Macintosh. If an internet enthusiast managed to pull it off after 30 years, surely Microsoft's own engineers could have done it back in the late 90s. Anyway, Wacko did all the necessary work, and now anyone can simply download the required files from his GitHub page, grab an original Windows NT 4.0 image, and install an original Windows distribution on their Power Mac. Not every model is supported, but several G3 and G4 machines are. The full list is available on GitHub. To be honest, I like Macs specifically for their operating systems and software. So I'm only covering this part today from a historical perspective. What we're actually interested in is a derivative of this release, named NT for Workcubes. The concept is the same. You'll need a GameCube, Wii or Wii U, a few files from the author's GitHub, and an original Windows NT 4.0 image. The console, of course, needs to be soft-modded or has a mod chip.
When choosing a test subject, I decided to go with the original Wii.
The reason is that it hits the sweet spot for this project. The GameCube is significantly weaker technically, meaning both Windows and any software will run much slower on it than on the Wii. As for the Wii U, Windows installs on it in Wii backward compatibility mode, so you don't really get any performance boost. Plus, my Wii U is an unmodded unit, and considering there are no major benefits, I don't see a reason to mess with it. So we'll just take a proper Wii and get to experimenting. Of course, and who would have thought, things didn't go smoothly for me as usual. Because you can't just take something that works for everyone else and expect it to work right away for you.
With Linux on PS2, I had issues because my console was too old. With Windows on Wii, I bumped into the opposite. My Wii was too new.
You see, in my collection I have this black Wii, already bundled with Motion Plus. It's still not one of those later cut-down versions that removed GameCube compatibility, but it is newer than the vanilla white revisions. And for some strange reason, actually not so strange and almost certainly related to a new motherboard revision, it's incompatible with the USB drivers used in NT for Workcubes. I started the installation process on it anyway. It's really quite simple. You copy the software downloaded from GitHub onto an SD card, add the English version of the NT 4.0 Service Pack 1 ISO to the NT folder, and rename it to disk00.iso. Then you need to create an empty hard disk image. The author recommends doing this through QEMU. No problem. A 2 GB image will be more than enough. Move that file to the same folder and name it disk00.img. Next, you launch the Homebrew loader on the Wii and run the installer. That's where I hit my first issue. The installer starts up, but in the device selection section where the SD card and our ISO and hard disk image should appear, there's nothing. I figured out the problem pretty quickly. My Wii had been sitting in a box for so long that the Homebrew channel on it was outdated and NT for Workcubes was built for a newer version. Luckily, in 2025, unlike Nintendo itself, the Wii is still actively supported by enthusiasts. Believe it or not, you can still update homebrew Wii software straight over the internet without a hitch. Just connect your console to Wi-Fi, launch the homebrew loader, and it will automatically install the latest update. Absolute magic.
The second issue I've encountered was the fact that my Wii doesn't recognize the USB keyboard.
During the device setup phase, you need to manually load drivers, the ones created by the author specifically for Nintendo consoles. There are 4 custom drivers. The bottom one is for GameCube specifically, for a GameCube memory card to SD adapter, which we don't need. The top one is for the Wii SD card. The second from the top is for the Wii's USB ports. And the last is for GameCube controller ports. 2 out of the 3 I need are detected on my Wii, but unfortunately, the USB one isn't. What's strange is that the GX loader works perfectly on this Wii, and a USB hard drive connected to it functions without any problems. You can control the installer using a GameCube controller and in the graphical interface. It even acts like a mouse, which is cool. We can format the disk and even start the installer, no problem. But as soon as we're past the initial setup and it's time to enter a username and product key, you're stuck without a keyboard. In theory, NT for Workcubes supports the official Japanese GameCube keyboard. But in 2025, and especially in Russia, getting your hands on one is way harder and more expensive than just grabbing an earlier Wii model from someone or buying one outright. So my choice was obvious.
Replace the console and repeat the whole process again.
On the earlier console model, everything goes smoothly. All 3 drivers are present, the system detects all the devices, and we just have to click through the remaining menu options in the text-based and then graphical installer, select all those familiar configuration settings, enter the CD key, and wait while everything gets copied and set up. Once the installation is complete, the installer will prompt you to reboot the system and will throw you back into the Homebrew channel menu. And in that menu, you'll now see the option to launch Windows. And that's pretty much it. Windows is installed on the Wii and you can now enjoy your freshly set up workstation.
Now let's immediately talk about the limitations. Yes, we've installed Windows on a natively supported CPU, but this is still a fan project, so there are a few gotchas.
There's no audio support in the project yet, so think of it like you're that middle-luck kid from the 90s whose dad bought him a PC but cheaped out on the Sound Blaster card. The author does say he's working on this, so maybe someday sound will be added to the build. There's also no network support, so you can't watch YouTube on your Wii just yet. Fortunately, transferring files is no problem at all, just copy them directly to the SD card. If you're like me and don't want to bother with PC emulators or hard disk images on an ordinary system, the simplest method is to take any CD image, open it in Ultra ISO, and just drag in the files you need. Then, replace the disk 00.iso file on the SD card with your new one, and Windows on the Wii will recognize it as a CD-ROM. The maximum supported resolution is 640 by 480. So if a piece of software or a game you want to run defaults to, say 800 by 600, it just won't work. Although in this case, it's not that much of a problem, because almost nothing will really work well here anyway. And that's a good segue into the topic of software compatibility.
And Windows on the Wii in terms of compatibility? Well, how do I put it? It's like Aquaman. Got it? No? It sucks.
The thing is, while we did technically run an official version of Windows for PowerPC processors on the Wii, not just an emulation, there's practically no official software for the PowerPC version of Windows NT. The software that existed for IBM RS-6000 was highly specialized corporate stuff, and obviously no one ever intended to share that with mere mortals. And besides IBM, let me remind you, the only other company that ever had any real use for PowerPC NT was Motorola. They released a few workstation models that ran this version of NT, and in fact, they were pretty much the only ones making any software for it. For example, Motorola had this machine called the Power Stack, a fairly powerful PowerPC system for the mid-90s with support for PCI and SCSI interfaces. Out of the box, Windows NT for PowerPC can support 16 and 32-bit DOS applications, but that's via emulation, and only 16-bit Windows applications work at all. So in practice, even with lag, almost nothing actually runs. And the stuff that does work? Well, let's just say even Doom runs something like this.
But hey, Doom does run, so at least we can check that out of the list.
Let me remind you, the Nintendo Wii has a 700 MHz processor and 88 MB of DDR3 RAM. For comparison, a 700 MHz Pentium 3 with 64 MB of RAM and a decent GPU with 3D acceleration could easily run games like Deus Ex, Diablo 2 or Quake 3. And here, we're struggling to run plain old Doom. The reason, of course, is that it's running through emulation on the Wii, and something like Duke Nukem 3D won't run at all. That's because we're trying to run software built for a completely different architecture x86 on a PowerPC. And 32-bit Windows applications won't work either, at least not out of the box. That's because Microsoft dropped support for the PowerPC version of NT after Service Pack 2. You can and should install SP2 manually here, but in terms of support for graphical applications, it doesn't change much. NT Service Pack 2 only supports up to DirectX 2, not even 3, which was the baseline for many more interesting applications.
This is where Motorola stepped in during the 90s to patch things up. At least just a little.
Because to run something like Microsoft Office properly on their workstations, which doesn't require DirectX, you still needed support for 32-bit Windows apps, which NT on PowerPC couldn't do by default. But if you install a special piece of Motorola software called Soft Windows 32, 32-bit apps that don't require modern DirectX versions can run. For example, Microsoft Office 95. Sure, performance won't be amazing compared to running it natively on x86, but it will work. So, in theory, you could deploy a Motorola Power Stack in an office, though I don't know why you'd bother when you could just buy a regular x86 PC that runs everything way better for the same price. Even something like the Earthworm Jim port for Windows 95 will run. Not that that specific game is particularly worth the effort to launch on a Wii, but honestly I tested so many Windows and DOS apps for this video that the fact anything runs is already a win, because the majority of stuff doesn't work in a whole variety of ways. Lands of Lore freezes at the installer. Dungeon Keeper loads the menu and lets you pick a mission, then crashes to a black screen. Carmageddon boots, then immediately freezes. Fallout 1, which forums say should run on NT for Wii, crashes with an error saying it can't initialize input devices. Though honestly, it was still worth launching just to witness the bootleg Russian installer from the 90s running on a Nintendo Wii. Now that's peak surrealism. Civilization 2 just crashes with a generic application error. Age of Empires doesn't even launch, it complains about the lack of DirectX 5.
Oh, right. I forgot to mention one more thing about DirectX.
Technically, most of the above shouldn't work at all, because NT 4.0 Service Pack 2 only supports DirectX 2, and these games need DirectX 3 or DirectX 5. But in recent updates, the developer of the Windows port for Wii added a patch that adds support for DirectX 3, 5, and even 7 under certain conditions. Some games still won't run, especially if they require specific Intel Pentium instructions or if they directly check the installed version of DirectX. But in theory, Age of Empires 1 should run with the no DXCheck flag. Just not for me.
Of all the Windows apps I've tested, the only one I managed to get working was Earthworm Jim.
Things are a bit better when it comes to MS-DOS applications, though still far from ideal. Even the simplest stuff like the original Leisure Suit Larry or Commander Keen refuses to work after the first screen. XCOM shows the intro, then crashes. Raptor Call of the Shadows behaves super erratically. I tried launching it 5 times, and each time it crashed at a random point before even getting to gameplay. On the 6th try, I finally managed to click through the menu to the start of the game, and it actually launched, but it lagged so much, it was basically unplayable. As for what did manage to run and was at least somewhat functional, the first Prince of Persia, although that wasn't exactly enjoyable either. It actually ran faster on my Chinese book 8088 in CGA mode than it does on a PowerPC Wii. Surprisingly, the original System Shock worked, and even more surprisingly, it ran better than Prince of Persia. So if you've got no other way to play the recent remake, hey, just grab a Wii and install Windows NT. Also working, the original Command & Conquer. Even the FMV cutscenes play. Albeit barely, but trying to move the map using a GameCube controller is hell. But here's the most important part, none of these issues are the Wii's fault. They're all down to Windows NT for PowerPC.
Even back in the 90s, no one needed this. So Microsoft dropped the support after Service Pack 2. The reason is the same: lack of interest.
If you try a native PowerPC port of Doom, like the one uploaded to archive.org last year by a user named NeoZed, it runs without a hitch. Of course it does, the Wii's processor is totally capable of handling it. And not just that, it's way more powerful than the CPUs this version of NT 4.0 was originally made for, but there are simply no native applications for PowerPC Windows NT. All I could find, and amusingly, it's still easily searchable online, was Visual C++ 4.0, along with an extra SDK disk for development. And that Doom port I mentioned? The author used exactly that SDK disk to build it. There's also Soft Windows 32 from Motorola, which I already talked about, and a disk titled Motorola PowerPC Demo Applications. There's a photo of that disk on the website of the National Museum of American History, but I couldn't find a disk image anywhere. Judging by the fact that it's listed under the section on computers in medicine and science, I suspect Motorola wasn't targeting personal users with its PowerStack machines. They were probably meant for industrial or medical use. And that's it. That's all the native software that exists. Sure, the presence of Visual C++ means more software could be coded, but let's be real. If no one cared about this in the mid-90s, absolutely no one is going to start developing for it in 2025. That Doom port was made just to tick a checkbox.
Because what piece of electronic hardware can't run Doom? Is it really an electronic hardware then?
And for fun, at the end of this whole adventure, you can poke around the standard games bundled with Windows NT, just to round off the software set for yet another delightful, yet utterly useless project. Personally, what I loved most about it was that in this age where everyone's obsessed with installing Linux on everything, someone out there thought, why not slap a 1-bit Microsoft's OS on a game console instead? Because as the old saying goes, when spouting nonsense, make sure not to spill a drop. Only pure nonsense is truly good nonsense. And Linux? It's been installed on everything so often by now that it barely even qualifies as nonsense anymore. Anyway, my dear viewers, I hope you enjoyed spending these half an hour with me exploring another fun little electronic experiment.
Thank you for watching today's episode. I really hope you liked it. Please press thumbs up, subscribe to the channel, and I'll see you next time. Have a nice day. Good luck!